Formula example part 2, what we're going to focus on is solving equations using our double angle formulas. So here's our first example. We want to find the exact solutions to this equation from 0 to 2 pi. And we give you this equation, the sine of 2x plus the cosine of x equals 0. And we want to find out what x can be. So I have the formulas on this sheet. We want to look at this double angle right here, the sine of 2x. Here's the sine of 2a, so I'm going to replace it with 2 sine of a cosine of a. So this becomes 2 sine of x cosine of x. And then I still have the rest of the equation as it is. Cosine of x equals 0. Now you've already learned how to solve trig equations. Some of the methods we learned is factoring, and then set those parts, the zero product property, equal to 0 and solve for x. So with this equation, I can factor out the greatest common factor. The greatest common factor for this equation is the cosine of x. So now what I'm left with is 2 sine of x plus 1. This is now factored. So now I'm going to set each factored piece equal to 0 and solve for x. Here's my first factor, the cosine of x equals 0. Here's my second factor, 2 sine of x plus 1 equals 0. Now we solve them separately. So we're going to use inverse trig, take the cosine inverse of 0. Well, I have the unit circle posted. Remember, the cosine is your x values on your unit circle. So I go around the unit circle. I'm looking for when the cosine has a 0 value. Here it is. So our angle is pi over 2. Do I have another one on the unit circle? Yes. Down here of 3 pi over 2. So far I have 2 solutions. Pi over 2 and 3 pi over 2. Now let's go to the second equation in the red. We still have to do a little bit more manipulating of this equation. We have to undo the plus 1, so we're going to subtract 1. And then we're going to undo the multiplying by 2 by dividing by 2. So now we have the sine of x equals negative 1/2. Now we're going to use our inverse trig, take the sine inverse of negative 1/2. So we go back to our unit circle. Remember, our sine now is our y value. So we look on our unit circle, where do we see negative 1/2 for our y? Right here at 7 pi over 6, and right here at 11 pi over 6. So this equation has 4 possible answers. These 2 in the red, and these 2 in the green. Here's another example. Now we have a double angle with the cosine of 2x. So we go over to our formula. Our formula has 3 choices. You can choose any of these 3. So if I choose this first one, let's see what happens. So I'm going to replace this cosine of 2x with cosine squared of x plus minus sine squared of x, and then we still have this sine of x equaling 0. The problem with this choice is you can't use that greatest common factor like we did on the last example. So I'm going to go ahead and erase that one. And I'm looking to see something that maybe has all sines of x's in it. So I'm going to choose not this top one, but the middle one, because it has just signs in it. So I'm going to replace this with 1 minus 2 sine squared of x, and then I still have that plus sine of x. Now I'm going to just put it in standard form. So I have negative 2 sine squared of x plus the sine of x, and then plus 1 equals 0. And what we have to do is not use greatest common factor like we did on the last example. We need to use our AC method. So if you remember AC, it's what are the factors of AC that add to B, and you convert it to grouping. So some of you like to not have that sine squared of x in there, so I'm going to use u substitution, 2u squared plus u plus 1. And we're going to use the AC. So 2, negative 2 and 1 is negative 2. We say, what are the factors of negative 2 that add to positive 1? So we get negative 2 times positive 1 is negative 1. That doesn't work. And then positive 2, negative 1, 1 works. So these are the numbers we're going to work with. And we're going to replace this middle term with those two middle terms. So we have negative 2u squared plus 2u minus 1u plus 1 equals 0. What we've done is we've converted from a trinomial to a polynomial 4 terms. We're going to finish it with grouping. So I'm going to group the first 2 terms and the last 2 terms. And we're going to pull out the GCFs. So the GCF of the first group is negative 2u. I'm left with u minus 1. In the second group, I can take out a negative 1. I'm left with u minus 1. Our parentheses must be the same, which they are, so that's my new GCF. And then my leftovers are the things in front. Negative 2 minus 1 equals 0. So what we've done is we've factored this equation with u's. So I'm going to replace those u's back with what they represent. The u represents the sine of x. Now we have it factored. So now we'll continue setting each factor equal to 0 and solve for x. So the sine of x equals 1. X equals the sine inverse of 1. Do this one next. Negative 2 sine of x minus 1 equals 0. Add 1 to both sides. Divide both sides by negative 2. And then use your inverse trig. I'm just going to pull down my unit circle to choose our values. So let's start with the blue one. We want to find out when is the sine, remember the sine is your y values, when do you see 1 on the unit circle? You see it right here. So your angle is pi over 2. So your value is x equals pi over 2. Now we'll head to the red one. When do you see the sine, which is your y value, of negative 1/2? Right here at 7 pi over 6, and right here at 11 pi over 6. So you have 2 solutions there, 7 pi over 6 and 11 pi over 6. So you have 3 possible solutions to this equation.